Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And I'm Philip Sage with the Manaway Group in Australia.
Hey, Philip, I know you're just heading into wintertime and I'm heading deep into summertime. It's good grief. We're at extremes.
Yes.
and one of the things I remember years ago, I was working with a company that wanted to put in tracking systems for solar panels. And their first big project was in the high desert in Arizona someplace, but in the high altitude desert. And they're in San Diego. So I had the impression that they had no idea what different temperature regions were like at all, because their test beds was on the roof and all of their environmental stuff was pretty generic, whatever. And I thought, all right, I know that somebody records weather data all over the world, different places and different weather stations. So I went to NOAA and looked up weather stations in the region where they were expecting this big project to be and gathered data. And I know you've done this where you get a data set and you say, well, what does it look like? What's the histogram of this look like? And it won't process the data. It won't give you a histogram because there's these text fields scattered throughout. So I got 10,000 points and I'm like, oh man. And so I'm trying to figure out what is this text message and how do I filter it? Or I had a whole slew of them at 99999. I'm like, well, that's a nonsense number. So it took me about 3 days to clean up the data. And the text message was essentially, as far as I could figure out, was that the weather station that I was pulling the data from was down. And I think, well, that's bothersome when I'm dealing with data, right? Yep. It's an indication of how harsh that environment is. So I was, in that case, I was able to get plenty of data. But we were chatting just before we hit record, and it's like, it's not uncommon that we deal with missing data. And sometimes they're harder than others. And you happen to be working on, what do you deal with left sensor data? So we could start with that one a little bit. And how do you go about dealing with that?
Yeah. Now, everybody's got challenges with their data. And, I think I saw at a conference once somebody asked who 250 people in the room, who feels they have good failure data. And maybe one person put their hand up and everybody smirked and kind of giggled.
Yeah. It's like, you don't know what you're doing, dude. Now, you can have really, really good failure data. I worked with one client that they made it so easy for their customers to send them failure data. And it was to meet a regulatory requirement. And so they gave them the bomb, they gave them a computer, any unscheduled remover. Was an aircraft industry. They were obligated to record it, but they made it so easy, and it was backed up on the cloud. And that cloud-ish thing, and they didn't call it that at the time, was back at the company. So as soon as somebody recorded a comm system, they got replaced, unscheduled removal. They had the serial number, what aircraft it was, the date and time, why was it removed, as far as they could tell, where is it going? Is it going back to repair? Or is it going back to the vendor? Or is it going back to the source? Was it thrown away? And they had the new model and what system was being installed, replacing it, and so on. And they had data within a day of just about every time something failed on these aircraft. And it was absolute gold for them.
Wow. Yeah, the best data I've ever seen is with a utility company, or several utility companies have different ranges of better data, and they are generally forced to, as part of their regulatory submissions every 4 or 5 years when they reset their pricing, of what they charge you as the customer. They have to analyze their fleet and report, especially in the area for capex, where over the next 5 years or next 10 years, you need to forecast how many of the assets you'll have to replace in order to still meet the customer reliability expectations and so forth. So the whole thing gets justified. So as a result, utility companies, like aircraft companies, for a different reason, have better records. And one of the challenges with utility companies, quite frankly, is the life of the asset is extraordinary. And there are assets that have been installed in the 1920s that are still in operation around the world.
Can you imagine the technology in those things? It's,
Yeah, very simple brute force, overbuilt, perhaps. We could make all those arguments, but the interesting challenge about the data sets that we don't even contemplate with utilities is computerization really didn't occur in a large scale in the business world until the early 80s, when those records were migrated off of paper for the first time into a computer database of sorts.
And it had to be the big folks that had some reason to really track that stuff, and going to computers from paper was justifiable. You've run into factories these days that still are using paper, and that's good enough. We're not paying a license for anything.
There are many different business models, and lean and agile versus traditional and conservative, and applying all of the time-honored traditions. They're very different. But the challenge with data is what do you do with the various types of data? For example, if your data set only begins in 1980, when
40-year-old equipment.
Yes, and you have 70-year-old life, equipment. You truly don't know the left-hand side of the distribution very well. And fortunately, a good majority, I should say, not most, a good majority of the assets do have an installation date, at least, that's credible. So you're able to say, okay, so since 1930, this asset has been installed and it's still in service today at the end of the data set, whether that's whatever date that you pulled the data on. And therefore, that's right censored, and it is, but it's also left truncated, because what we don't know from 1980 back into time is how many assets were installed before 1980 that failed before 1980.
I've never thought of that before. Is that I always was looking at, well, I don't know when it was put into service. I always treated that as a left truncation, but you also need the other bit of information. Well, out of how many?
Yes.
Yeah.
So
okay.
you need to, left truncated data needs to be treated with special care, and you actually have to compensate for that in the algorithms in order to deal with the fact that you don't know anything about the left tail of the distribution. And that is a challenge. The other problem is in 1980, you apparently have done a survey, and you have found that you have 1,000 power transformers on the network, but you don't have installation dates for 100 of them. Now what do you do?
Yeah.
When did they get installed, right? How long have they actually been in service? And especially if they're still in service today, they will be right censored in the traditional sense, but the value of the time value from 1980 to whatever date, might be 40 years worth of service time, is not the correct time value.
Yeah.
Right? Because it was installed before 1980, and you don't know really when that was. So how do you guess?
Yeah. No, I was reminded me of one project I did where, and it was just generically, it was a data set that was missing, say, 10 data points. And not a huge data set, but it was missing 10 points. And it was a combination of it just wasn't written down, it wasn't recorded, or it was a clerical error. And instead of 3 digits, it was 7 digits. And I was like, well, which 3 do I pick? you know, kind of thing. And so I just fit a distribution to the data that I had and use that to say, where would these missing ones most likely be? Mm-hmm. And just kind of scattered them into the distribution and added them to it and saying, well, I'm going to fit what I have and pick a thing like that. In hindsight, if it was before a particular date, so that say our records from 1980 prior were lost, then I would fit a truncated distribution to it, the existing data, but that still wouldn't get me the ones that were installed but failed. That would be tricky. But I think I could guess by just thinking through, well, what do I know? Do I know it's before a certain date? Is that where it is? Or is it random throughout my distribution? And where would they likely have been if it was not, I didn't know a prior date? There's other techniques too, is you ignore them completely. I've seen that plenty of times with failure data. It's customer abuse. We don't use that data. And I'm like, what? Come on. I don't know. I'm trying to think. That's the one I've used a couple of times. Is just use the existing data, predict where the other ones would be. And I know it's got some faults and stuff. Time series. I did a time series once, and we were talking about, or I mentioned weather early on. If I needed, if it's kind of our missing was the number of shipments we would have, and I knew it was on a time series, I would use that to bridge the gap instead of doing a linear, instead of saying it's halfway between March and August or March and June. Yeah, those are 2 months apart. And draw a straight line. I could use the time series pattern of shipments to smooth that out a little bit better. That's my boss called that overkill when I showed him what I was doing. He says, "Get back to work."
But the challenge is, what do you do with a data set and how do you find these problems? What I found to be extremely useful, and I wrote some code in Python to generate a event chart effects. One line or a bar, and I start back because I've dealt with utility equipment. I start back in 1900. And then on the x-axis, bring that forward to 2024, and I plot the installation versus the failure date, and a little dumbbell or a line with a couple of little indicators or squares or stars at the end to mean different things. And what you're able to see is very quickly that you've got data problems of all different varieties. In some cases, because your data set only really records, we'll use 1980 as the example we've been using. You have some assets that were installed in the 30s and 40s, but you realize very quickly that that's maybe 5% of the assets. And what you don't know, and you can kind of deduce from the size of the urban area that you're pulling that information from, another, gives you another source of indication, is that that area was electrified. So there would have been power transformers, for example, or power poles.
Well, you could say there would be some number would be there just from design principles. Yeah.
Right. So you know for a fact that you're missing some. So the topic of left truncation is a very big one because we don't know how much of the left tail has been truncated off of the life distribution. The other challenge that we mentioned is in 1980, you have transformers that just appear in the network, or I've run into, in the 1996 era, a utility company absorbed a different utility company and inherited all their transformers. But when they did so, they didn't get any data on the installation date. So all of those...
They fictionally started in 96.
Right.
Boom, they're
So
here.
yeah, they're right here, right? So we need to do something with the left date in order the left side of that data point in order to make it more realistic and there it's all various degrees of guesswork at that point, as to how you compensate for that.
Well, there's one thought though we haven't touched on yet, and is if you run the analysis without all the guesswork, is it sufficient to answer the question you're going after? Or if you do some manipulations and basic guesswork, just saying, oh, well, let's just spread those out, which is a simple method, will it change the answer?
Well, that's an important business discussion, isn't it?
Yeah,
Right? Should you invest the time in order to get a more precise answer? And often, I think the answer, if it's more than just a couple of data points, the answer is yes. And certainly, when you plot the timeline and you see evidence, 5% of the assets are still there from the 30s, but you have a pretty good idea that you're missing maybe 30% or 40% of the real data set if you
right.
had recorded it, then I would suggest that you need to do more work.
Yeah,
And we need to understand the other nuances of when whether we use the term suspended or censored. Censored is a statistical term. Some folks in the reliability field use suspensions
yeah,
to mean a censor. Um, and at the right side of the timeline where you stop your data set, we need to understand that those are probably are really are right censored, but sometimes we select right censored for the wrong reason. And Lagakos is pretty good on describing the concept of informative and non-informative censoring. And that topic, if we have informative censoring, what that basically means is that because that transformer is looking old and about to fail, I'm going to take it out of service. But because it didn't actually fail, I'm not going to count it as a failure. I'm going to check the box for suspension or censoring.
hmm,
And that is not correct for the following reason. Because it is about to fail, and what we don't know is that we know how long it was in service before we chose to take it out, and that it was going to fail pretty darn soon in relative terms based on our estimation. We have information that says that is not part of the right tail fully.
right.
And
It's a truncated right tail or abbreviated right tail or whatever the right term is. But that's an interesting point. And I never, and it affects if you're doing predictive maintenance. How do you treat that pump that you are saying the probability of failure now due to its use and condition in our last inspection is that it's got maybe another month on it, and
yeah,
you proactively replace it. Yet the traditional right censoring is, well, we just don't know. And it could go to the six decimal, the six sigma uh, point out there, or it could fail tomorrow. But that
right.
widens out tremendously when the expected time to failure is.
Yeah. Well, when we, I guess theoretically, say that it is right censored, we're basically saying that it can, uh, as a random variable, end up anywhere in the right tail.
Right.
And when we informatively censor and say this one's on its last legs, it has no chance of getting into the far reaches of the right tail. And it's probably better to treat that as an actual failure, even though there is error in the time value.
Yeah. It might
What
have
you
had another month or 2 months or a year or whatever, but it's not 10
right.
years.
Yeah, you could add on average, if you're running a program to, for example, to replace CTs in the distribution network, for example, and you're doing an inspection every 5 or 6 years, and based on the results of that inspection and measurements, you're making a determination, and you've got so much money in your budget to replace so many CTs a year, so you're going to take out the worst ones. You could probably say the average is maybe 2.5 years or 4 years. You can
Mm-hmm.
make an estimate, and that would be the error that you would add into those data points as a best guess or best approximation engineering estimate of when that would estimate, and then treat it as a failure with error rather than a right censored data point.
Because it affects the fitting algorithms at that
Sure
point.
does.
Yeah.
Sure does.
Well, this isn't your standard run of the mill software package.
No, no, unfortunately, very few software packages, if any. I mean, they're people have to get deep into the topic to get it right, and very few of the software packages that are available actually cater to these types of problems. So as a result, you could say most likely very few of the commercially available software packages ever render the right result if you have a data set that has these problems. And my experience is working with engineers in industry is that they often don't know about these problems, and therefore they often select the wrong type of setting, whether
Yeah.
it's censored or not, and don't compensate for left truncation ever, or the errors. And
Well, I've
in
also seen engineers that say, well, we're dealing with failure analysis data here, so we're just going to track the failures, and they ignore all the ones that are still operating. Uh,
Yeah, yeah, yeah,
and their
yeah,
plot shows 100% failure. And they're like, well, how many are still running? Oh,
yeah,
hundreds and hundreds of them still running. Well,
yeah.
okay.
That brings up the whole subject of having a few failures in the left tail and trying to out of 1,000, right? You've
Yeah.
got 20 failures out of 1,000 out of 1,000 unit population,
How
and you're
many do I need for next month's repair cycle? Like,
right, or how many am I going to have to replace in the next 5 years?
yeah.
Or typical capex budget questions.
Well, then it shows that it's an infant mortality problem. And so, like, well, yeah, then I think then you have to know that something's not right. We can't predict this thing yet. I've seen it done. People will do it and go, oh, we had 3 this month. We're only going to have 1 next month, and then won't be any after that for a long, long time.
Yeah.
Okay.
My experience with the commercial software packages, even when you deal with right censoring, is the only true data problem that you have, other than complete records,
Yeah.
is that they typically from the 1960s, Hurd and Johnson developed the technique of the mean order number, which then looks at the order of the times to failure from the smallest to the largest,
Mm-hmm.
and then you have this group that extends beyond the edge of the window of observation and are effectively right censored because you don't know when they're going to fail, but you assume that they're going to be part of the distribution. But the mean order number actually takes a pretty linear approach to altering the median rank. And when you get into situations of extreme censoring, you begin to realize that if you look at the 99th percentile calculation, which is pretty easy to do,
Yeah.
that your asset is expected to live 115 years, and or at least 1% of the assets, and that becomes phenomenally impossible. And therefore, you realize that the algorithms that are being used are delivering completely unsustainable results in some situations.
Well, that brings up a whole nother topic. It's kind of and I always thought it was a question that came in a couple days ago, and I thought, oh, maybe we should talk about that. What's the difference between quality statistics and reliability statistics? And the biggest, without tipping the hand, I think everybody knows, is that we deal with things that don't happen yet. So in college, we're taught in basic statistics, never extrapolate, but we do it all the time. It's just fraught with problems and pitfalls. I don't know. That might have to come back and talk about that one. But
Yeah, that'd be a good topic. And actually, reliability engineers should, in my opinion, be heavily trained in statistical process control or quality control techniques, because there's an awful lot of good knowledge that can be gained not just from a data processing state, but from a process control or understanding whether your process is in fact performing reliably.
Yeah.
That's a really great question to be able to answer. And the Reliability Performance Index that I developed probably about 20 years ago allows you to do that, actually.
All right. Well, let's come back to that one.
All right.
But yeah, we all have to deal with missing data or data that we know is just should be there, but it's not, or it's recorded incorrectly, or it's missing the vital bits of info we need. And not accounting for it can really skew the results you get. And if it's $1 million question, you probably need to spend some time to go sort it out and make some educated guesses or do the due diligence to sort out, well, how are you going to deal with this? Whether it's from the statistics side, the analysis side, or what other information you have that you can use to fill in the data, to flush it out a bit. So there's a handful of techniques there, and every situation is different. So it's going to take some creativity on it. Yet it's ignoring it for major analysis, and when you're going to be making big decisions that are expensive to get wrong, it's very likely you'll get it wrong if you don't take care of the missing data or the suspect data types of things. So if you got questions on this, or if you have got a clever way to deal with missing data or left truncation, let us know. Head over to accendoreliability.com/go/SOR. And Philip and I are available on LinkedIn and our About pages. And as just a quick the LinkedIn was where I got this question about quality versus reliability statistics. So I thought it was an interesting topic. I didn't want to dive into it too much, but then I thought, wow, maybe Philip, you and I should talk about that. So that might be on our next episode. Stay tuned. You'll find out. So with that, Philip, I think we'll truncate. We'll make sure that we have an end point to this, so we're not going to be right censored on the length of this. I don't know how I'd put that on the sheet, how long the episode is, because I think it's tracked automatically. So it's
yeah. If our voice suddenly stops, we've been right censored.
There you go. That happens. We have technology problems every now and then. Anyway, thanks so much, Philip, and good luck with your left sensor data. It sounds like a lot of fun.
All right. Thanks, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.